Okay, today we're going to go over the first fundamental theorem of calculus, which is a way to find both the value of a bounded integral, and it serves as a quick shortcut for finding a value at a specific point. It's very versatile, and it will come up a lot in both calculus AB and calculus BC. So this is the equation. That is, if we let the derivative of capital F of x equal f lowercase f of x, meaning that this over here is the antiderivative of this over here. And if you were to take the derivative of this, you'd end up with this. So it states that the integral from a to b of f of x dx is equal to the antiderivative at point b minus the antiderivative at point a. And that's basically it. Okay, sorry if that the background info was a bit short. There really is not much to go over. It's pretty simple. So we're told here to find the value of the integral from 2 to 3, 4 times x minus 2 squared dx. So let's first write down the general equation for the first fundamental theorem of calculus, that being that the integral from a to b of f prime of x dx is equal to f of b minus f of a. So the first thing we're going to do is we're going to want to find the antiderivative of the integram here. So the integral of this term over here is 4/3 x minus 2 cubed plus c, although when dealing with bounding integrals, we don't have to deal with plus c, which is great. So this over here is the antiderivative. Basically, if you don't understand how to do this, I've made a video in the past going over I believe it's called the power rule with differentiating. This is essentially the inverse of that. And if you don't believe me, if you don't believe that this is the antiderivative minus the c of this term over here, this integram, then we can simply take the derivative and we can see that it is in fact equal to 4 times x minus 2 squared. So we have our antiderivative. Now we just need to plug in b and a. So we can say that the integral, or sorry, just this term over here from 3 to 2 is equal to what we can plug in here, 4/3 3 minus 2 cubed minus 4/3 2 minus 2 cubed. Now this over here is of course equal to 0 because 2 minus 2 is 0. 2 minus 2 is 0. 0 cubed is 0. 0 times 4/3 is 0. So this entire term over here is equal to 0. And what we have over here is going to be the value essentially, and we can simplify this a bit. It's actually equal to 4/3 times 1 cubed, which is in fact just 4/3. So the value of the integral from 2 to 3 of 4 times x minus 2 squared with respect to x is equal to 4/3. So as I said earlier, the first fundamental theorem of calculus not only serves as a way to find the value of an integral, but also a specific point. In this case, we're going to try to find f of 1 if f prime of x is equal to 3x squared and f of 0 equals 1. So the first thing we're going to do is write out the general term, or equation, I should say, for the first fundamental theorem of calculus, which is the integral from a to b of f prime of x dx is equal to f of b minus f of a. And so we can already begin to fill in terms here. You can see that the parameters we're going to use in place of a and b are going to be 0 and 1. We can fill that in over here as well. And we already have f prime of x. It's 3x squared. So our derivative, our integram will be 3x squared. Now, from here, we already have most of the process done. We have the integral from 0 to 1, 3x squared dx equals f of 1 minus f of 0. However, we in fact already know what f of 0 is. it's 1. So all we need to do now is solve for f of 1. We can take the antiderivative of 3x squared, and it's pretty obviously x cubed. Again, if you don't understand this, check out one of my earlier videos over the power rule. So now all we have to do is find the value of x cubed from 1 to 0. And that will be equal to f of 1 minus 1. And what we're essentially going to do here is employ the fundamental theorem, first fundamental theorem of calculus again. So x cubed at point 1, sorry, at 1 minus 0 cubed is equal to f of 1 minus 1. And from here, we can just simplify, I suppose. This over here is equal to 0. This is equal to 1. So we end up with 1 plus 1 equals 2 is equal to f of 1. And so the value of f of 1 in this sense is going to be equal to 2. That's it for the video. If you have any further suggestions, please put them in the comments below.